Here you can see a two-line coal grinding plant that produces coal dust for use in the steel and iron industry, which has the same structure as a self-inert central coal grinding plant. If the plant is to be used in the branches of industry mentioned in the introduction, certain plant components are adjusted to meet the specific requirements of those sectors. The current state of the art dictates that a considerable proportion of the reducing agents needed in blast furnaces is injected into the blast furnace through blow molds in the form of coal dust. This technology is known as PCI, pulverized coal injection. The plants used to produce the coal dust were designed as self-inert coal grinding plants. In 1986-87, Loesche had a major role to play in developing these systems. The first such plant came online in Germany at Rogesa in Dillingen. Now we will show you how the plant is structured. First, we will follow the flow of material from raw coal to coal dust. Then we will see the path that the process gas takes. The raw coal is transported on a conveyor belt to the raw coal bunkers, which are mounted on load cells. The material is usually discharged from the raw coal bunkers via drag chain feeders, which are steplessly controlled and equipped with a regulator for height. The raw coal is fed in centrally via the classifier or from the side of the mill. The raw coal is dried and ground in the mill. This one is a Loesche mill type LM28.3D. The required product grain size is achieved by means of a dynamic Loesche classifier. The coal dust process gas mixture is fed to the bag filter via process ducts. The bag filter is where the coal dust is separated from the process gas. The coal dust leaves the filter system via discharge units. The connected rotary valves form the air seal to the plant components that are conducting process gas. Chutes transport the product to the fine coal silos. These fine coal silos then link up with the conveying systems of the PCI system in order to transport the product still further. Heat must be fed into the system in order for the dry grinding process to be carried out. This is where a hot gas generator system, developed and patented by Loesche and consisting of a steel combustion chamber, known all over the world as a Loma heater, and a multiple lance burner comes in. Blast or coke furnace gas is used for coal grinding plants in the ironworks industry, with synthesizing gas or other available gases used for coal gasification plants. Cleaned gases leaving the bag filter are heated up to the temperature required for dry grinding in the hot gas generator. The hot gases are then transported to the mill via ductwork. The coal dust process gas mixture leaves the mill via the classifier and reaches the bag filter, where the fine coal is separated out. The cleaned process gas leaves the filter. The cleaned process gas is forwarded to the process gas fan via ducting. The fan generates the pressure difference required by the grinding process. Once it leaves the process gas fan, the whole volume flow of gas reaches the flap system, where it is divided into a component that exits the system via a stack and another component that is fed back to the mill's hot gas generator via the return gas duct. A venturi tube in the return gas duct measures the volume flow. As aforementioned, there are 4 major industrial sectors where Loesche coal mills are being used. Loesche is always one step ahead.